Hello everyone, and welcome back to another video. And we have something a little bit different today. You'll see I have Desmos pulled up. And the problem we're basically solving, and that I kind of came up with a little while ago, is basically this problem of, so we have exponential graph and this log graph, both of base A. And my question is the problem is basically, at what point of A do these intersect at exactly one point? Because you'll see if we increase this, and keep increasing until, I don't know, so you get to the natural log and actual exponential, they don't intersect at all. But if we actually decrease this down to say 1.24, it's like you'll see, oh, okay, well it has 2 points of intersection. So the question is, at what point in between here do they have exactly 1 point of intersection? And you can kind of see here that it's like 1.44-ish. So basically, the whole goal of this problem is to basically find, what value of A do these intersect, and also we'll find the point of intersection while we're at it. So yeah, let's hop onto the OneNote. So now that we're in the OneNote, what we can see that what we clearly have is an A to the x is equal to log base A of x, for x is our point of intersection, and then A is our base that we're trying to find. But one thing that you'll also notice from the Desmos is that if you look at it close enough, you'll also note that because these are inverse functions of each other, both of these must actually be equal to x. So we can kind of rewrite this as almost like a compound equation. X equals a to the x, which is equal to log base a of x. And this is one of the very helpful things, and it kind of allows us, at least one way, to solve a problem. And the way we're actually going to be doing this is noting one more quite significant thing. So if you actually look at the graph like one more time, I know I keep referencing it, but there's a reason I showed you the Desmos. So you have our y equals x here, and we have our exponential. I can different colors, can't I? We have our exponential graph here, and we have our log graph here. And basically, what you'll note is that this line y equals x is actually tangent to both of these graphs at our point of intersection. And another way you can think about that is actually the derivative of, x at this point is going to be equal to the slope or derivative of our both a to the x and log base a of x. And that's actually what we're going to exploit to solve this problem. So what we're going to do is basically differentiate both sides and kind of see what we get. So the derivative of x is clearly just 1. So we have 1 is equal to the derivative of a to the x, which is just a to the x times the natural log of a, just by differentiation rules. Now we also know that this 1 is going to be equal to the derivative of our log base a term, which by properties of logs is just going to be 1 over x, or properties of derivatives. You get the point. Whenever you differentiate that, you get an x times the natural log of a. And we know that both of those equations are true, but we're actually not going to set them equal to each other because the resulting thing is a bit nasty. So what we're going to do instead actually is just, we have an x here, and we have a pretty nice expression in terms of x there. So all we're going to do is just kind of solve for x. So what we're going to do then is just say, x is then just equal to 1 over the natural log of a. Meaning that whenever we sub this in right here, what we're going to have is a to the 1 over natural log of a is just going to be equal to the natural log, it's going to be equal to 1 over the natural log of a. And the reason I'm writing it like this is because, let's just simplify this term right here. What we're left with, if we kind of rearrange this, we get an e to the 1 over natural log of a, but then times the natural log of a if you take the natural log and then raise it to, then you exponentiate it. You'll note that these cancel, meaning that we're just left with e is equal to 1 over the natural log of a, meaning that, if we just solve for a, what we're going to get is a natural log of a is equal to a 1 over e, meaning that our a is actually just equal to e to the 1 over e, which is that approximately 1.44 number. Now I did also say that after we found the base we would find the actual point of intersection, so yeah, let's try to do that. It's actually really not that bad because, well, x is actually just, well, we know from above that x is just equal to 1 over the natural log of a, and we already have the natural log of a here, so x is actually just e. So what we have here is actually quite nice. Is we have our point of intersection. I'll scroll up back here. Our point of intersection right here is actually just e, comma e, and then our base a is just equal to e to the power of 1 over e. So yeah, here's a short little fun problem for y'all today, and I hope y'all enjoyed. See you in the next one. Thanks for watching.